students? Last time we verified Ohm's law. We verified Ohm's law, isn't it?
Yes, sir.
Today, by God's grace, we are going to find the internal resistance of the cell. Now, this is the diagrams we are going to be using to find it. An ammeter is connected to a cell. This is the cell. Now, the cell is this. The battery is our cell. Now, this cell is connected parallel to the voltmeters. This is our voltmeters. This is connected parallel to this. Let me myself clear. Parallel to this. Series to the what? To the key. This is the switch. This is our key. Is the switch. Are you seeing it now? This is our key. It is a series to this. Series to the what? Rheostat. Now this is the rheostat. This is the rheostat. This is serial connection to the rheostat. There is serial connection to the what? To the ammeter. To the what?
Ammeter.
Now let us calculate, find the internal resistance of this cell. And now we meant to understand that at the end of everything, we are going to be having voltage is equal to our cell, our total numbers of cell minus our current times R. This is the what? Our internal resistance R. We are going to make R the subject of the formula. We are going to find R, which is our what? Internal resistance, which we are looking for. Do I make myself clear? Voltage, which is from the voltmeter, will be equal to what? Our cell minus with our current that we got here. Isn't it?
Yes.
That times the internal resistance. And this is called the lost voltage. The lost voltage. Do I make myself clear?
Yes.
Now we are going to start the connection now. Now, please Solo come here. We're going to start. Let's quickly start the connection now. Now, this is our switch, our battery, our cell, our switch, our cell. Now, connect our battery. Quick. Don't have time. Connect it with the rheostat. Now, we are starting with our rheostat. We are starting our connection with the rheostat. That is our another name for rheostat is called variable resistor. This is the variable resistor. Now, from our rheostat, we connect it down straight to the key, to the switch. Now we are connecting it straight to the what? To the switch. Now you connect it down to the switch. Our switch is open. Look at it. It's open. We are connecting it down straight to the switch. As you can see the connection, we are connecting it down straight to the switch. You ensure the connection is being tight very well. Now the other leg of the switch is connected to the cell. This is the cell, the battery, the cell. Please, we are going to do this calculation in the class, the theoretical calculation. This is a practical calculation. No? I will tell you, I will ask you in exam, find the internal resistance for me. I may ask you in exam, find the what? The current for me. I may ask you in exam, find the voltage for me. You better listen now. Good. Now, the cell, connect the right leg of the cell to the ammeter. To the positive side of the ammeter. This is the positive side of the ammeters. As you can see, this is the positive side of the ammeters. Connect it. Tie it very well. Now, this becomes a closed cycle. Now, let our voltmeter be in parallel together with the cell. Now, our next leg of the rheostat, from the rheostat, from the negative side of the ammeter, now we are connecting it to the what? To the variable resistor, which is the rheostat. We are connecting it, the negative side of the ammeter, straight to the what? To the rheostat. Here's the rheostat. Another name for it is the variable resistor. Tie it very well. As you can see, now make sure this is connected parallel to this. Good. Good. Thank you very much. Now make sure this is connected parallel to the cell. Now look at how we are connecting it parallel. When you normally used to hear parallel connection. Now from the voltmeters, we are making use of 3 volts. We are making use of 3 volt value. Or let us make use of 5 volts. Should we make use of 5 volts? Okay, let's make use of 3 volt value. This is a 3 volt value. Why this is the what 5 volt value? As you can see, we are connecting the voltmeter parallel to the what? To the cell, to the battery. Now it's going to be at the what? The positive terminal and the negative terminals of the cell. Now look at it. Now look at it. When the switch is open, did I close the switch? No. Did I close the switch?
No.
This is not laughing matter. You better focus now. Did I close the switch?
No.
Now this is the value of the voltage. I did not close the switch. Oh. What is the value of the voltage? As someone should tell me, what is the value?
2.7.
2 point what?
7.
Now look up. The value of the voltage is 2.7. Now voltage. Our voltage is 2.7 volts. That is our value. Good. When the what? The key is what? Open. When the switch is what? Open. I open the switch. Now look up now. I will close the switch now. Did they say I have closed it? Huh?
Yes, sir.
Solo close it for me. Now, when I close the switch, what is the value of the voltage?
1.3.
2.3.
Huh?
1.3.
1 point what?
3.
Now, the value of the voltage when we close the switch, when the switch is closed, key, close. Voltage is what? 1.3 volts. Now, what is the ampere? The ammeter reading, which is the current?
0.86.
0. What?
86.
0.86 amp. Look up, oh, good. Now we have our ammeter reading to be 0.86 amp. Now our voltage to be what? 1.3 volts. Now look up. Our cell, look up. This is my cell. The battery, each of them is 1.5. This one is 1.5. This one is 1.5. Look at it here. 1.5 volts. 1.5 volts. If you add the two together, it becomes what? 3 volts. Now our cell E is what? 3 volts. You know I got a 3 volts. I add the two batteries together. 1.5 plus 1.5 give me 3 volts. When you know this thing, any question on internal resistance, you can be able to answer that question with this practical. Now, the next thing, look at it now. I want to calculate my internal resistance out. My voltage is given to be 1.3 will be equal to 3 minus current times internal resistance. What is the current? 0.86 amp. Isn't it?
Yes, sir.
Now I'm looking for this. Let's 3 come to this side. I can now say 1.3 minus 3 is equal to 0.86 amp. Now, 1.3 minus 3 is what?
Minus 1.7.
Minus 1.7, isn't it?
Yes, sir.
Yeah, is equal to 0 minus, look at it, this is carry minus 0.86 R. Now, minus will cancel minus. We have 1.7 is equal to 0.86 R. You divide by 0.86 divided by 0.86. This will cancel. Our internal resistance will be what? 1.7 divided by 0.86. What do you have to be your internal resistance?
1.97.
1.97. This is our internal resistance. 1.97 will be our internal resistance. Now, resistance is measured in what? Ohms. You put your ohms. You value unit. In physics, we have value unit. Now, please, back to the practical. Now, this is our rheostat. Come and adjust it. Adjust the rheostat. Look up now. Adjust in little. What is the value of the current? Just adjust it.
Wait.
Our value of current is what?
0.2 amps.
Good. Now, our current now is 0.2 amp. What is the value of the voltage? Voltage is what? 2.1 volts. Now, what is our total cell?
3.
Good. Our total cell is 3 volts. Now, let's calculate the internal resistance. Now, internal resistance, you now write 2.1 is equal to what? Our internal resistance, which is 3 minus 0.2 times what? R. You have 2.1 minus 3 is equal to 0.2 minus 0.2 R. This is minus 0.2 R. Now, minus what do you have?
Minus 0.9.
Minus 0.9 is equal to minus 0.2. Now, minus we cancel minus. We divide by 0.2, divide by 0.2. This is our R. Then R will be what?
4.5.
4.5.
Eh?
4.5.
4.5
5
ohms. This is our internal resistance. Are you following on?
Yes, sir.
Now, you can adjust it again, the rheostat. The more you are calculating it, the more you adjust the rheostat again. This is the rheostat. You are adjusting the rheostat. As you are adjusting it, the voltage and the ammeter, they are all moving. Are they not moving? Now, what is the value of the current? Put it at the 0.4. Place it at 0.4. Move it little. Yes, okay. Well, now, the current is at 0.4. What is the voltage?
1.8.
1.8. Now, the voltage is what? 1.8. The current is what? 0.4. Isn't it?
Yes.
The cell is what?
3.
3 what? We have 3 volts. Now, calculate the internal resistance. That will be your assignment. You calculate the internal resistance for me. Thank you very much. Now, in exam, maybe in YF, we cannot say it. We cannot say it. They will not say you plot the graph of voltage against what? Current. Are you getting me? We are going to plot the graph of voltage against current. That will be in our next class. Then we are going to use a graph book to plot the graph of this. Do I make myself clear?
Yes, sir.
Now, internal resistance is the opposition of what? Flowing of current. Are you getting me? The opposition of what? Flowing of current becomes what? Internal resistance. This is a practical of what? How to find internal resistance of the what? Of a cell. Any question? Thank you very much and God bless you.